Question 19 says that the lengths of the two legs of right triangle ABC shown below are given in inches. The midpoint of segment AB is how many inches from A? As answer choices, we have a bunch of two-digit numbers ranging from 16 to 40. And another thing I'm noticing here is that there is a doubling relationship between B and E. And there's also a doubling relationship between A and this number 32 in the prompt. Noticing those relationships among the answers, we're going to want to be extra careful about possibly doubling or having something as we do this question, because it seems like the ACT might be predicting a mistake related to that type of thing. As far as the ACT math concepts involved in this question from reading the prompt, we're dealing with right triangles as well as this idea of a midpoint. And a midpoint is just the point that's exactly halfway between two other points. And another concept that's not stated directly in the prompt, but that we want to be thinking about given a right triangle as well as two sides, is the Pythagorean theorem. Because whenever we have a right triangle with two known sides, we'll always be able to calculate the remaining side using the Pythagorean theorem or using our knowledge of Pythagorean triples if we're familiar with that. As far as approaches on this question, there's really only a formal way of getting the answer here. So I'm going to type that out up here. Approaches, we have the formal way, which is basically going to involve finding AB and dividing that by 2. There is one other way that we can not really get the answer, but that we can double check ourselves though. And that's by using the scale of the figure to basically eyeball the length and confirm that our answer is reasonable. So I'm just going to write that out here, eyeball to double check. Let's go back to what the question was asking us for, which is basically the midpoint of AB is how many inches from A. So I'm going to draw a little dot here to indicate approximately the midpoint of AB. And we're trying to figure out how many inches away from A that point is. And before we actually solve this question, I want to pause here for a second and just pose the question of, can we predict just at this point what a really common mistake someone might make on this particular question would be? Can we predict a wrong answer that the ACT has planted among the answer choices to catch us if we're not paying close attention to detail? And I'm not going to actually answer that, but take a second for yourself to think about that. And once we finish doing this question, we'll look at the wrong answers and see what some common mistakes would actually be. All right, so going back to this, we want to get this distance. And as I mentioned earlier, we're first going to want to calculate the length of side AB here using either the Pythagorean theorem or Pythagorean triples. So with the Pythagorean theorem, that is just a squared plus b squared is equal to c squared. And our known sides here are 32 squared plus 24 squared. And we don't know the hypotenuse, which is c. And I'm going to take out the calculator to do this calculation. So we got 32 squared, which is 1,024, and then 24 squared, which is 576. So we're going to be adding those together, so plus 1,024, and that's going to be equal to c squared. And then we're going to take the square root of that to find c. So the square root of 1,600, and that's going to be 40. So I'm going to write that out right here. C is equal to 40. And so now we've calculated the length of A to B, which is 40. And since they were asking for the distance from the midpoint of that to A, this length right here is going to be 20. So our answer here is going to be B. As I mentioned earlier, another way to calculate the length of AB is to use what's called a Pythagorean triple. And a Pythagorean triple is just a set of 3 integers that follows this particular formula. And one of the common Pythagorean triples that appears on the ACT is a 3, 4, 5. Another common one is the 5, 12, 13. And you can quickly check that these both satisfy the Pythagorean theorem. And what's cool is that any multiple of these numbers also satisfies the Pythagorean theorem. And if we notice that 24 and 32 are actually in this ratio of 3 to 4, because if we divide 24 by 8, for example, this will be 3. And if we divide 32 by 8, that will be 4. So we have this 3, 4, 5 sort of ratio. Then we can quickly see that this side, a to b, is going to be the 5 version of it. And we can see that both of these are being multiplied by 8. So this will be 5 times 8, which is 40. Now, that's more of a shortcut to solving this. So if you haven't learned those, then you can always use the Pythagorean theorem like we did earlier. Now that we've seen the formal solutions to this question, let's take a look at this second solution that I mentioned earlier. And in this case, it's not really a solution as much as a way to double check ourselves. And that is to use the scale of the figure to just eyeball it visually and make sure that our answer makes sense given the context. And the reason that we can do this is because the ACT has given us a figure here. And unless they say specifically in the question that the figure is not drawn to scale, every single figure I've ever seen on any ACT math section always is basically drawn to scale. So for example, here we want to confirm that our answer 20 is reasonable. And we can see that this length of 20 from here to here, it is in fact less than this side here, which is 32. So that makes sense. And it's also less than this side down here, which is 24, which also makes sense. On the other hand, if we had got an answer like 40, and that from here to here was 40, that would not make sense given the scale. And the same thing with 28. If we had gotten that as an answer, that should raise some flags when we visually try to check that, because from here to here, if that were 28, it seems smaller than this side, which is 24. So it seems like something's wrong. Now let's take a look at the wrong answers. And as I mentioned earlier, this is a great question to practice predicting possible mistakes that the ACT is setting us up to make. And in retrospect, we can really see what was going on here. We had seen in the answer previews that one of the relationships here was this idea of doubles, where B is essentially half of E. And we can see why they did that. A mistake that would be very easy to make here if we were rushing would be to see this right triangle in the beginning and kind of read the question really quickly, then sort of see that, okay, I have to calculate a to b, use the Pythagorean theorem, get 40, and then circle 40, move on to the next question, forgetting that we're actually trying to find the midpoint. And so 40 here is a very tricky kind of trap answer. We can see a similar thing going on with answer choice A, which would be if we had misread the question and instead of finding the length of the midpoint from A to B, we had found the length of the midpoint from A to C, since we had seen earlier that 16 is half of 32. Answer choice D of 28 could reflect the mistake of finding the average of 32 and 24 for some reason. So if you do 32 plus 24 divided by 2, that is 28. As far as answer choice C, 21, I'm not exactly sure how someone might get that, other than that if we were to assume that in this right triangle, the 32 was actually the hypotenuse and use that for our C value, then the approximate value we would get out for A to B here would be about 21. It's like 21.16. And so that would involve a couple mistakes though, because then it would also involve forgetting to divide that by 2. But that's a possible reason why that's there. Now let's think about what we ultimately needed to know for this question. We'll type that out over here. Ultimately needed to know. Well, first of all, we needed to know the Pythagorean theorem, or Pythagorean triples, which is equivalent. And the other thing, we needed to know the definition of midpoint, or at least be able to kind of reason through what that would mean. And those are the two only things here. And finally, as far as the ultimate takeaways from this question, this is just another example of how the ACT tests us on pretty basic math concepts, but in very detail-oriented ways that are kind of setting us up to make small mistakes unless we're very careful about them. So for example, answer choice E, as we had said earlier, someone who got that, they essentially understand the Pythagorean theorem, so they understand the main math concept that's involved here. They just forgot what the question was asking and were in a rush, and so they got 0 points for the question. In addition to this question just being another example of that theme. It's also a great example of how we can avoid those types of mistakes and even catch them if we do happen to make them. So one of the first steps we did was to notice this relationship among the answers, that we have these doubles and these halves. And as it turned out, they were expecting us to make a mistake in terms of doubling and halving. And having that awareness from the previews of the answers would give us just more of a heads up to double check our stuff and be really careful about that. The other type of thing that I personally like to do that helps me sort of avoid these mistakes is when I read a question like this that's asking me for something very specific, like the midpoint, then I'll go ahead and label it on the figure so that I don't forget what I'm trying to find. Just because the ACT knows that we're conditioned in high school to have solved many right triangles, like hundreds or thousands of times, and it's like a conditioned response to just find that missing side, circle an answer, go on to the next answer. And they've designed this question taking advantage of that tendency. A very similar thing that they'll sometimes do is they'll ask, for example, for the value of 2x in a question instead of just x. And one of the wrong answers will usually be x, because they know that we've been conditioned over many years of schooling to solve just for x. So try to find opportunities to label stuff like that, or, at the bottom of the page, just like write down 2x, for example, equals question mark, so you don't forget what you're actually solving for. And then the last sort of actionable tool here that we saw to help us catch any types of mistakes like this was using this way of eyeballing our answer to just confirm that we got it right. And that could have helped us if we had gotten 40 and then we had reread the question and just sort of seen that visually that does not make sense given the scale of the figure. So that pretty much wraps things up for this one. Let's go on to question 20.